Hi friends, today we discuss technical question answer in electrical branch for preparation of different state PSU. So first we discuss about DC machine objective question and answer. So DC machine is again divided into two categories, one is DC motor and DC generator. So first we discuss objective question answer related to DC motor. First one is the counter EMF of DC motor. Option 1 often exceeds the supply voltage, aids the apply voltage, help in energy conversion, regulates its armature voltage. Counter EMF means back EMF. Obviously option C help in energy conversion. Then question number 2. If a 230 volt DC series motor is connected to a 230 volt AC supply, so what happens? Option A, the motor will vibrate. Option B, the motor will run with less efficiency and more sparking. Option C, the motor will not run. Option D, the fuse will be blown. Obviously, the motor will run. Option B, the motor will run with less efficiency and more sparking. Then question number 3. The value of back EMF EB in DC motor is maximum at no load, full load, half, full load, D none of the above. Option A is correct, no load, because we know that V equal to, in case of motor, V equal to EB plus IA RA. So at the time of no load, the armature current is 0. That means the back EMF is maximum. Then come to last one. Wave winding is employed in a DC machine of high current and low voltage rating, low current and high voltage rating, high current and high voltage rating, low current and low voltage rating. Generally, wave winding is option B, low current and high voltage rating. Similar question also as lap winding is employed in DC machine for just opposite, high current and low voltage rating. Then come to question number 5. If the field of a DC shunt motor gets opened while the motor is running, then the speed of the motor will be reduced. The motor will attain dangerously high speed. Armature current will drop. Armature will oscillate about original speed as the main speed. So here the option B is correct. The motor will attain dangerously high speed. Okay. If the field is open, that means total current is flowing through the armature. No field circuit, only total current is flowing through the armature. At that time the motor will attain very high speed. Then come to question number 6. Question number 6. In a large DC series motor, why is shunt field winding provided? Option A, to avoid field distortion. Option B, to generate working flux. Option C, to improve commutation. Option D, to avoid runaway speed at no load. Because the no load speed in a DC series motor is very high. To avoid runaway speed, so in case of large DC series motor, we provide the shunt field winding. That's why the series motor is always run with load. Okay. Then question number 7. If the current in the armature of a DC series motor is reduced to 50%, the torque of motor will become 50% of previous value, 25% of previous value, 150% of previous value. Option D, 125% of previous value. We know that in case of DC series motor, the torque is proportional to the square of the armature current. That means when the current is reduced 50%, that means the torque becomes automatically, if you calculate the formula T2 by T1, put the value in the formula, you get that 25% of the previous value. Then come to question number 8. A 250 volt DC motor has an armature of 0.25 ohm. It is drawing an armature current of 25 ampere, driving certain load. Calculate induced EMF in motor under this condition. We know that equation V equal to EB plus IARA. So we have to calculate EB. EB equal to V minus IARA. Put the formula. V is here 250 minus I armature current 25 into resistance 0.25. The answer is B, 243.75 volt. Then come to question number 9. In DC motor, the speed depends upon applied voltage, back EMF. Option C, back EMF and flux. Option D, flux. We know that N is proportional to EB by phi. So both option C, back EMF and flux. The speed is depends upon back EMF and flux. Then question number 10. What is the relation between speed and armature current in case of DC series motor? Speed and armature current inversely proportional in case of DC series motor. So obviously N is option A, N proportional to 1 by Ia. Same question again, also ask similar type of question. What is the relation between speed and torque in case of DC series motor? Directly proportional, inversely proportional, torque proportional to square root of speed, D, T equal to N. Option from the characteristic, if you draw the characteristic of between speed and torque, the speed and torque is inversely proportional. When the speed is more, torque is less. When torque is more, speed is less. Okay. Then question number 12. Why series motor is used for traction purpose or locomotive purpose? High starting torque, low starting torque, high speed, low speed. Obviously series motor high starting torque. So option A is correct. Again come to question number 13. Voltage equation of DC motor is given by V equal to EB plus IARA. Option A. B, V equal to EB minus IARA. V equal to EBIA minus RA. Option D, V equal to EBIA plus RA. Obviously V equal to EB plus IARA. Option A is correct. Then come to question number 14. Brushes are provided in the DC machine for option A, smooth rotation, preventing sparking, providing path for flow of current, reduce the losses. Providing path for flow of current. Then question number 15. The induced EMF in the armature conductor of a DC motor is sinusoidal, trapezoidal, rectangular, modified. Obviously the induced EMF in the armature conductor is AC. AC means the waveform is sinusoidal. Then come to question number 16. Which of the motor is used for rolling mills? DC shunt motor, DC cumulatively compound motor, DC series motor. Option D, DC differentially compound motor. Option B, DC cumulatively compound motor. Then come to question number 17. Fleming left hand rule is applicable to DC generator, DC motor, option C alternator, option D transformer. So option B is correct, DC motor, because Fleming left hand rule is used for to indicate the direction of the force. Okay. So friends, today we discuss various question and answer related to DC motor. So next video we also discuss more question in different topic. Thank you.